Down here,
Okay, everybody, so we're at that point in the evening when,
He's one of the richest.
yeah, I had him up earlier in the morning and he's tired. Unfortunately, he's in the same time zone, so we can't count on that. But he's been drinking wine and it's late.
Boy, this table knows that.
He's well lubricated.
Now we can start asking him don't turn it back up. Did I turn it off? Yeah, there you go. Okay, that's good. That's good. So now we can ask him the questions that we want. These are the real key questions, like is any of this real and really that stuff. I don't know, whatever. But the future of mankind. But maybe you guys have got the questions and key questions.
We already did that.
Okay, so you're on. There you go.
All right, well, first, everybody, thanks a lot for coming. I really appreciate it. Turning out. It's just awesome. It's so great to participate in this because it reaches so many levels in your community, and it's such a community thing. So thank you to the supporters, and thank you being out tonight. You're all supporters in at least that sense. I'm happy to try to answer anything. We've been doing a lot of sort of the seamy underbelly. Hopefully we can raise it back. Higher plane. Yes.
Okay, it's me.
it's always your
It's always me. First of all, I learned a new word in the program. I was sure in my head it was a typo. All the way through was hominin, and you always said hominid. But there's this new word hominin, which is just the human branch, and the hominids includes the apes, which blew my mind. I learned more English tonight, which I'm cool about.
You can just forget it right now.
Okay.
Hominid is what Darwin called our clade. That's the fancy word for it. It's our side of the branch, right?
Yeah.
Hominid, that's what Darwin said. And he struggled with this. He actually, as I said, thought about an order quadrumana, and he settled on family level of the zoological hierarchy. When we find a fossil they don't have labels on, we get to give them a label, we call them what the hell we want, right? There's this little issue of priority, but things bounce around depending on where you do things. Okay, well, you're going to make the division. So it's always a family level that has distinguished us from the other apes. It's equivalent in a zoological level to Hyenidae, which is a family, the hyenids, or Ursidae, the family of bears, or Canidae, the family of dogs. We are the family of hominids. Right? That's cool. That's cool. All the way through George Gaylord Simpson, the last century's greatest human paleontologist, mammalian paleontologist, paleontologist of vertebrates, whatever you call them. Good enough for him, good enough for me. But
That was George Clifton.
a movement arose called cladistics during the 1970s and 80s.
Here's my question.
And they started calling it hominid. So some people call it that, some people call it hominid. It means exactly, they're synonymous.
Okay, so let's say I'm a science fiction writer. I admired Isaac Asimov because his science was pretty good, even though he was writing science fiction. And I want to write science fiction, and I want to not be ridiculed by your corner, people who know the stuff. So, projecting forward, I would say the hominids will divide into three. There will be those who go to Mars and evolve there. There will be those who stay kind of like us on the Earth's surface. And there will be those who go underwater and evolve the ability to breathe somehow, more like fish, I don't know, live underwater. Because underwater is yet to be conquered by us, quote unquote, conquered. Does that sound like realistic science fiction? 100 million years from now, looking back, we've got hominids on Mars, underwater, and on the Earth's surface. How's that?
Well, I like parts of it.
Okay.
I like the part of it that you've isolated small populations in very different environments. Because that creates selective pressures that can drive evolution. That's happened among mammals. That's cool. I like that. The underwater part of it, The reason we can go there and even know about it is because of technology and culture. And why the hell would anybody ever give that up to breathe with gills and go back to that, right? I mean, that's very unlikely.
So it's gonna be a technological hominid down there.
Well, by definition, hominids have been technological for 2.7 million years. Culture is part of our biology is part of culture. It's all one thing. So now, let's think about Earth, those of us who are unlucky enough to stick around here. Right? We've continued to create greenhouse gases like crazy. And we've set up selective gradients, but we've got a population of billions of people, right? Well, among the billions, some of us are probably less susceptible to lung cancer at an early age. So their genes are going to come to dominance on planet Earth. And of course, we've inherited, even with our small, relatively speaking, testicles, these male agonistic behaviors from our close ape relatives. And they now take the form of nuclear weapons, and we can now reduce population size on the planet very quickly and effectively. Right? Setting up an even better environment for evolution to proceed. So that's a problem. With fiction, you can do a lot of it and have a lot of it make sense. But that's the neat thing about historical science, is when you look back, the past only happened one way. And our job as we see it is to try to get at it as accurately as possible, to read it as accurately as possible, and to represent it as accurately as possible. Yes?
Yeah, I wanted to take a little issue with your one of the statements you made about sound bites, or by 3-minute blips in science. Do you remember that?
That was the radio guy who suggested that I do that.
Oh, okay.
And I'm actually not very good at it.
Yeah, I don't think any true scientist would be very good at it.
Yeah.
Because I was reminded of one of my former students, is a researcher up here at OFHU, and she had an intern come in for a stint for 3 months, and the intern was really PO'd, and she was from high school, because she didn't have something she could make into a science project yet. And this whole attitude that everything has to be a soundbite, or not longitudinal, is absurd.
Well, unfortunately, it's really altered the landscape of science. And the way that happened is very insidious. Because the people who run our universities, the people who run our granting agencies, are competing for that, what used to be 15 minutes of fame. And now it's a 3-minute soundbite. And your tenure, your promotion, your laboratory space, your support staff, all that depends on you saying something, often incredibly stupid, but newsworthy, because it's so incredibly stupid. And so, people are doing that now routinely all the time. I mean, I can take this testicle thing on the road and it goes nuts, and it give me promotions and bigger lab.
I think you put on the table with the reporters.
They've got all that. What's that?
Was become nuts an intentional pun?
Oh, man. I told you this table needs to be brought to extinction right now.
I really think we missed the boat, though, because when virtual reality came about, we should have jumped on it like nobody's business in the gaming industry, because science is interesting. And unfortunately, the things you see in the gaming industry are not realistic. And I was reading a report where kids today, early age kids, if you put a ball and drop it and ask them what's going to happen to it, they don't know. And we could have jumped on the gaming industry as scientists to make some very creative kinds of things. In fact, the Human Interface Laboratory up by University of Washington is trying to do that.
Got a question over this table.
There's so many.
Yeah.
I think you were first, though.
I have a word question too, and I know that somewhere in the back of my mind I know this, but I cannot remember, so I hope you don't mind answering this. Where did the names Australopithecus, obviously wasn't found in Australia, And the name of your find, what are the derivations of those words?
Yeah, the Australopithecus, when people find a fossil of something new, they get to name it. Whether it's really new or not, they still name it, especially these days, because it gets the media attention in 3 minutes. But in those days, a guy named Raymond Dart, who was an anatomist, was presented by a student of his with a with a baboon cranium, and he told the guy at the mine, okay, if you find any more of these, send them to me. So the guy at the mine sent him this thing, and it was a block, and he chipped it all out of the block, and he went, holy crap, this thing is, he was an Australian guy, but that didn't have anything to do with the name. Austral means just south, and he called it Pithecus to mean ape, because of the tiny brain. So he called it the southern ape. But he saw features in it, like the placement of the spinal cord going into the brain, that he thought meant that it was more related to us than to apes. And the British establishment, because he was in South Africa, he was young, and he was an Australian, for God's sake. They hammered this, and nobody accepted Australopithecus, because the British had their own fossil at the time, which was, of course, Piltdown.
Whoops.
Yeah.
How'd that go?
Don't worry about it. Yeah, so that's where that comes from. Now, when we found this thing, what we do for the local people, they're not going to enter into the PhD level anytime soon, right? They're Islamic camel herders and subsistence pastoralism, right? It's going to take a generation or two. But one of the ways that we sort of honor their culture is to name everything that's new for something in their language. So Ardi means ground. This is a ground ape in the terms that they can understand. And we've done this. We found an Australopithecus that we call Gargi, which is a surprise. It was a surprise to everybody because it had such big back teeth. So we use the Afar terms for all those site names that I put up there. We use their geographic terms and so forth, just as a way to keep that cultural continuity in place. So that's where those names come from. But we get to make the names up. So if there are any of you in the audience that have approximately $1 billion, I'd be happy to name a new aardvark specimen with your species name next time you find a new species of aardvark.
Will you take a check?
Or an IOU. Over here, you had some.
Yes.
You had some in the back too.
There can't be limitless fossil inventory. When do you think, if you think, we'll ever run out of bones to discover?
Well, what we're working on now is fracking.
Is that
That's my next lecture. Yeah, we're going to frack the crap out of the Afar. And we're going to have this stuff in. We're going to be able to push Putin all over the map with our fracked fossils, right?
Push peak fossils out.
I've actually published on this topic, and I'd be happy to send you the scientific paper on it.
Well, how do we know what's left of the
timwhite@berkeley.edu. And the fact of the matter is that these are non-renewable resources, and they're very concentrated in these areas. And they're very susceptible to things like agricultural development. We found incredibly rich sites in southern Ethiopia that have now been completely wiped out. Not by anybody with any malintent. These are subsistence farmers growing maize. And they're just chewing things up and planting maize. You can't see the fossils anymore. Oh my gosh. Dams, flooding areas that aren't surveyed properly. There are lots of, and these are countries that don't mitigate these kinds of things. We have, environmental impact reports and stuff like that in this country, and we don't mitigate very well either, right? The Emeryville Shell Mound, a great example in California. They steam shoveled it in the early 1900s. Berkeley archaeologists did some work there and saved a lot of culture from that shell mound. But yeah, it's a threat to these resources. But on the flip side of that, you have a place like Aramis, and every time it rains, new fossils are exposed. And so we're on it's almost like potato farming or something, We're on a regular revisitation cycle where we go in and collect the new things that come out. But what we find is we never achieve the kind of richness that greets you at a newly discovered site. The problem is we've discovered most of the new sites already. The Lucy site, to give you an example, was found in 1972 by a French geologist who then showed Johansen where the place was. They went in and collected it. The museum collections are in Australopithecus, but you can go in and it's a rhino skull and a crocodile skull and a hippo skull. Beautiful stuff. Beautiful fossils. If you go out to the site today and just look around, you won't find that. Maybe once every 20 years you'll then find another skull, because these surfaces are accumulations of fossils from centuries back. They come out to the surface and they stay there. They kind of break apart and you put them back together again. So it's a non-renewable resource, kind of, and it's kind of a renewable resource. The problem is they're so thinly scattered on these ancient landscapes that if you just go in and dig, you're not going to find anything. You have to do it like we did with Artie. With Lucy, she had already completely eroded out of the sand channel and all of her bones were on the surface. That's why she doesn't have any hand and feet anymore. They all washed away before they got there to recover them. So when you think about that, this is the sort of, I don't like to use the word miracle very much, especially here. We don't have the stained glass, but isn't it amazing that 4.4 million years elapses, and if we let this erosion continue for another 30 years, we end up with a handful of teeth if that little hill erodes away, because all the rest of that bone just disintegrates.
Why do you wait then? Why don't you dig down?
Yeah.
Because we don't know where to dig. These landscapes are kilometers. If we dig, we'll get some elephants, we'll get some pigs and stuff like that, but we're not going to find hominids. They're not dense enough. The only place you can do that is in these natural accumulating traps in South Africa. So there they dig, and they actually find stuff. The rest of it, we have to take a surface signal and use that as our indicator to dig. Maybe the same question you could ask in a sense, it's like a forensic case, right? Oh, Joe Blow is missing. Let's go find him. Where do we dig? Oh, call the psychic in, right? Well, we haven't done that yet. We're not that desperate.
Where you found Artie, would that be, if I'm going to keep going down, would that be a logical?
Well, you can keep going down, but you're going to get into, pretty soon you get into a volcanic ash and it gets pretty sterile. And we know what happens up section because we've got 300 meters of that section right there. And if you imagine standing there, if you could stand there for, let's see, the sequence starts at 5.2 and it ends up at 3.8 million. All right, so 5.2, 3.8, I'm not very good at that, especially after all the wine and these characters on this table.
1.4.
All right, so if you can stand there for this long period of time in one place and just observe what's going on around you, if you could live for 1.4 million years and just be an observer. Or, better yet, put a video camera there, because most of it's just boring as all hell, right? But you see animals passing by, occasionally a hominid passing in front of the video camera, you capture that, and so on and so forth. Except the problem is, shortly after that woodland, supported by groundwater, that Artie lived in, was there. There was a river channel. And after the river channel, there were tectonics downstream. And the whole thing turned into a lake basin. And then there was a local volcano that blew up. And we got the most amazing fossilized fish in the world. They could have put these fish on your plate tonight and you would have tried to cut them. They got the scales, the heads, the whole damn thing. You'd think it was part of the meal. They're that well preserved. But you wouldn't find any hominids in there. Just the fish. It's the wrong habitat. You're sampling there. So you got to get the right habitat when you're looking for this. And that's what I think one of the big problems. It's kind of unrealized. Why has it been so hard to find these really ancient pre-Lucy fossils? Well, because the animals themselves were very restricted in their habitat requirements. They were ecologically very tightly constrained.
And I guess they never had graveyards.
No way. That comes way later in time.
Oh, yeah.
So basically, you're looking at incredibly smart organisms who are pretty high on a food chain. They're pretty low in population density. And unlike mice, they don't turn over every 2 or 3 years. So you got lots of dead mice carcasses. Those pile up real fast. These hominids live for a long, long time, so you don't get many dead ones on a landscape. So they're really, really rare. And it's been really, really a big challenge to find them. So we've got to use whatever indicators we have. One of the things that the Ardi stuff, I think, helps with is we've now sort of circumscribed the habitat that we expect to find them in, and so people can now concentrate on sites that have colobus monkeys and kudus and peacocks and those kind of animals you'll find frequently, but you then hope that you find the rare hominid fossil there. So that's the hope for the future. Yes?
You've been talking about how difficult it is to get this new knowledge. I remember in junior high for the first time hearing about Australopithecus, and I am blown away tonight, and I'm just feeling fortunate that I have lived this long to gain this new knowledge. And it's, to me, there is this expansive amount of information that has been gained, and I really feel blessed that I'm a recipient of this evening. What I want to know is, in my lifespan, what do you want to, what do you expect, what do you hope, what do you think we may then find? Because it's been really, you may think it's been slow, but there's been a lot that I didn't know then that you just talked about tonight.
Well, a lot of this is now thrown into the mix, these new data, and they'll be debated for a long, long time. I'm one of those people who think we should spend more money, more time, more effort in expanding the evidentiary base. And the best way to do that is via the field work. Now, obviously, that field work has to be supported, not just by institutions and individuals that give money to this, but also by the sort of luck of the draw, the geological circumstances that underlie making this stuff available. If you'd have asked me 20 years ago what would come out of the former Soviet Georgia, I would have told you probably not much. Now it's one of the most important hominid occupation sites on the planet. It's 1.8 million years, the first hominids out of Africa. Incredible insights into our evolution, the variation of these, it's an early Homo erectus, whatever you want to call it. Biologically, these are the creatures that first expanded beyond Australopithecus into Eurasia. Fantastic, and a Georgian colleague has found those. They're developing infrastructure, museum training, the whole thing. It's just incredible. That's it. But it's in a space the size of this room. The size of this room, and it was found by pure shit luck that a medieval settlement was founded at this place, which is a crossroads near the old Silk Road. And as these people dug down into the basements of their medieval houses, they hit this fossil deposit. And years later, paleontologists came along and went, holy crap, there's fossils in the basement. Right? but they weren't paleontologists. They were the ones brought in by the archaeologists who were digging up the medieval settlement. Who went, holy crap, there's a saber-toothed cat down here. What's that doing in the Middle Ages, right? And so then they excavated a little bit, and then they found this stuff. So it's really great. So it's very difficult to predict. The one thing you can predict is if you're not out there looking at the reef, if you don't have trained people, if you don't target this stuff, you're not going to find it. If you sit around and waste all your money in a lab on, microscribes and measurements and all the stuff that my colleagues do, we do it too, but we also have a field dimension. A field dimension costs money, it costs time, and it costs effort, and we got to put more time, money, and effort into that field research. Now, I'm not just blowing hot air here, because some years ago, when there was more money at the National Science Foundation, they had a program called Hominid, and I forget what the acronym was, the human something or other. Anyway, they had $2 million awards. That was like the $2.5 million. That's the biggest award that NSF offered in this field of research. It was a special award category they created. So we applied. And the people in the Beltway got the money first. What a surprise. Smithsonian, influence, dinners together. It's the Beltway, for God's sake. I should have known better than to apply. We got rejected. So then we applied again. And then we had a meeting with the head of the anthropology program at SF, and he said, well, you know, sorry to tell you this, but we're gonna have to fund some primate research here. And I had the guy that worked in Chad, the paleontologist there, at the same meeting with me, and he says to the NSF guy, there are many people watching you. And he did it like a mafioso. It was really great. And so we got the money. So now we got $2.5 million, right? And so now that's not chump change. Now we can start to do some interesting things with this. And so what do? We basically, to get the money, I had to say, all right, we're going to administer this program, but we're not going to take any of it for the Middle Awash, because heaven forbid we spend any of that goddamn money on the site that's the most productive, longest, most fossils, best dated, whatever. I'm not going to touch the damn money. I'm just going to hand it out like Robin Hood. So take from the rich and give to the poor. And so we gave money to the Greeks, to the Spanish, to the Chinese, to the Kenyans, Tanzanians, to other projects in Ethiopia. And we found a lot of, our target was the last common ancestor. You said, what would you go for? I want to see what that thing looks. I'm not even sure I can recognize it, but I'd sure like to find some 7 million year old apes. Whether chimp, gorilla, you know, whatever they are, I'd love to get in there. I got several problems. I don't have the money problem anymore, right? And the ecology problem, I think maybe I've worked out what ecologies to look for. Now I've only got a problem in finding where the hell are patches of these rocks. So I've got all these people in China and Spain and you know, all over the place, Africa, everywhere we can think of, we funded that. And we've got the sites that already yielded some of these things. In Chad yielded a few more, Ethiopia yielded a few more, and that was basically it. And we learned about gorilla origins from a site on the southern margin of the Afar Rift that's still being worked today. In fact, last week the guys were out there in the field working on this. So we know more about gorillas than we've ever known in terms of their fossil history, but it's still just isolated teeth. And we found out a lot about some very strange organisms that live in Turkey 7 million years ago. Bizarre baboon-like apes in their postcranial skeleton with great big back teeth that look like Australopithecus. It's a new genus called Ardipithecus. They're not hominids, but they're part of this adaptive radiation of apes across the entire old world. That's cool. That's awesome. And we jump-started all of these projects. They're now gone back to their countries or their universities or whatever it is to keep that kind of stuff going. So, you know, it was, we didn't get what we hoped we would get for the $2.5 million. We got a lot of information. We published something like 400 scientific papers out of that project. Now, you might ask, what about the Beltway project?
Funny you should ask
It's
that.
not finished yet. We're still working on it.
Have they started?
Yeah, they started, but they got a little bit distracted because there was an issue. And one of the big private donors to go back into the area of this, you all know David Koch? Oh man, what a reaction. Too bad I didn't have a video camera. So Dave, your reception in Portland was, shall we say, mixed. But, yeah, he's a buddy of mine. I was with Dave down at Lullaby Gorge one time. When I found that crappy skeleton I showed on the screen, Dave was there. Me and Dave go way back. Dave's a supporter of Don Johansson. Dave's a supporter of the Smithsonian.
Yeah, you hear this thing when Nova comes up, supported by David Koch.
Always David Koch. Now, David Koch supported the NOVA program. I got a colleague at the Smithsonian, in fact, the guy who got the first $2.5 million, a man named Rick Potts. He's an archaeologist. Now, Mr. Potts, Dr. Potts, he did his degree. He was Harvard, maybe Yale, those Ivy League guys. He thinks that climate change created us. Now this philosophy goes quite well with Koch Industries. Yeah. So if you go to the Human Evolution exhibit, funded to the tune of $15 million at the Smithsonian Institution, money I might point out, that bought very nice bronze busts of these early hominids, but did very little to advance the science. And the money on the NOVA program. You watch that NOVA program, You get a lot of talking heads saying, yeah, by God, we're here because of the climate change. Hell, we evolved because of climate change. It claims so radically. Hell, that's okay. That's the way it is. Has been called greenwashing.
Yeah, right.
Green. This table knows all about that. So, but David Koch does a lot of good things with his money. David Koch funds paleoanthropology. He funds the Hadar Project, the ongoing work at the Lucy Project. We know the Lucy species today, going back to your question, so much better than any hominid species. And when I started in this profession in the 1970s, we didn't know anything about the Lucy species.
Yes.
That's incredible. I never would have thought in my lifetime we could find out so much about such an ancient species as we have found out now, about the contact, environment, all that kind of stuff. And that came from NSF money, came from David Koch money, but more importantly, it came from the work of the people who are out there in the field actually collecting that evidence, and the people in the laboratories analyzing it. And you need both sides. And I'm afraid that in this field, we've gone too far toward the 3-minute soundbite. This is stuff you don't do in 3 minutes, you don't summarize it. And that's why I lectured for so long tonight.
I'll tell you one anecdote. I had a professor, he made a fire up at Berkeley, and he very erudite guy, he's an opera, he was always a front seat of the operas and very well educated. He also used to go to the Texas wrestling stuff. You know, it was like Gorgeous George versus something like that. And somebody asked him one time, said, how is it you're this, you know, incredibly educated, sophisticated guy, you're going to this Texas wrestling thing? He says, it's the only place you can tell the good guys from the bad guys. It's very clear. I mean, David Koch, what is he, a good guy or a bad guy?
Yes.
From the Lucy area, do you think, and this is I don't even know if you'd be in a position to know this, do you think, assuming that we're not attacked by animals or disease or anything, could they live as long as we live, or have we evolved to have a longer inherent lifespan than they did? Or could Lucy have lived 80 years if nothing attacked her?
Well, it's probably a combination of the two things. What we find is that the average time of death is really low, even a few hundred years ago relative to us. Sure. So obviously, you know, the biology hasn't changed, it's the culture that's changed. If you go back as far back as Lucy, she died when she had just achieved adulthood from whatever, maybe a croc got her, maybe it was disease, we don't know. Same thing with Artie, she's got an infected toe, maybe that knocked her off. Usually in forensic sciences, we can't make the diagnosis, but we can look at the demographic profile. We can see how many really elderly individuals there are. By 1.8 million years ago, we've got individuals from this Demonese site in Georgia that don't have any teeth left. Very dentulous. There were no dentures as far as you know, they're clearly some kind of social support system was in place, and you know, call that social, call it culture, or whatever you want to call it. The culture has been part of our biology, and our biology has been part of culture ever since the first ones started knocking sharp flakes off of stones, and probably even before that, based on the evidence of the great apes. So in terms of overall longevity, it's the culture that has primarily allowed that in modern humans. Whereas lifespan in organisms in the wild, you can look at chimps and see how they do it. You know, a 40-year-old chimp is a very, very old chimp, and so that has a lot of implications for our own health. It used to be, I had a colleague named Ms. Sarah, she was a biochemist at Berkeley. He's the guy who did the initial chimpanzee biochemical work compared to humans. He'd go into his class and he'd say, you know, people talk about we have an epidemic of cancer in this country. Actually, we have an epidemic of old age. You know, and so the answer is there are two parts to that answer. Yeah, it's biology. We probably, on average, holding everything else constant, can run longer before we croak. But a lot of that is not the biology, it's not the natural selection, it's the culture allowing that to happen with everything from social support systems to technology to enable people to live.
So the Lucy tribe, people that she was, all of a sudden were transported to our time, and we gave them the benefits of all our technology, they probably still wouldn't live as long as we would.
Probably not. It'd probably be, for example, chimps and gorillas in zoos. I don't know, Natalie knows more about this than I do. What about lemurs in zoos? You know, they live longer than they live in the wild.
They probably do. I mean, an animal the size of a lemur, say take a lemur cata, this is a lemur that weighs maybe 3 kilos. Sometimes in captivity, they'll live to be 25 years old for an animal that size. That's a really long lifespan. And that's, compared to other mammals, primates are long-lived. We are relatively long-lived as an order, as a group of mammals. But that is really long-lived for an animal that size. Up to 30 years for a lemur that weighs a couple kilos.
We're getting late in this. The woman over here has had her arm up. This is going to fall off. Dedicated.
I was told earlier in the evening that when women want to get into what you do, they tend to kind of choose the like studying live specimens, and when they want to get into studying fossils, they hit kind of a glass ceiling. And I was wondering if you knew why that was or anything like that.
Well, it is for lots of reasons, and it is across the sciences. It's not just paleoanthropology. You see the same thing in biology. You see the same thing in some parts of social sciences. There is no sort of conspiracy on the part of the male individuals in the discipline. You could ask the same question about men studying primates. Why don't we hear of very many men studying chimpanzees? Why is it always Jane Goodall and Diane Fawcett, you know, like, role models are a really important thing. And we've got, balls. We have Me Leakey is an extremely prominent paleoanthropologist. Mary Leakey was a prominent paleoanthropologist at her. So there were role models there, not as many as the men. And then I think another factor that a lot of people don't think about very much, I think about it a lot, because my wife does this. She doesn't do it in the same country, you know, we can't work in the same country. The thing is, a lot of these cultures, these developing country cultures, like the Islamic people that I live with, in the field for 2-3 months out of the year. A woman tells them to take the sack of grain out of the car and put it on the ground. Are you kidding me? A woman? Really? So there's a cultural bias that is inherent in these societies that makes it a lot tougher for a woman to operate at that level. They don't expect women to be in those kinds of positions of authority. And this is true not just for the Islamic guys down on the ground. It's true in the Christian highlands. I think we don't often appreciate that the sort of egalitarian, the opportunity-based system that has developed in this country, really only in the very recent generation or two, is far from taking hold in most of the rest of the world. And unfortunately, there are no hominid fossils in Montana. And if there were, I think that you would also see a change in those kinds of percentages. So there are several hurdles there, and I think we have to keep working on all of those hurdles. But I think that, you know, I see this not from the point of view of gender, as in such stark contrast as I see it from the point of view of race. Because take your question and rephrase it. Why don't you see black professionals in this field? In South Africa, why is it always the white guys talking about the fossils? In Kenya, in Tanzania, why? In Ethiopia, until this generation. Now we can see the change, right? And a lot of that has to do with role models. The guy who found the child at the Lucy site, very important child skeleton, probably about a 3.5-year-old kid called Lucy's child or Salam. He's an Ethiopian guy. I took that guy to the field for the first time as part of an inventory project in the 1980s. Dr. Burhani served as the role model for him to follow in the footsteps of a PhD. The geologist, the same way. So role modeling is really, really important. It's hard to do this, but it's possible to do this. But it threatens the status quo. And what we've done in Ethiopia is really threatened the status quo of paleoanthropology. And there are a lot of people who have big, big stakes in the status quo. Laboratories, graduate students, access to grants, access to field sites. They love that colonial system. They don't know anything different. And they're very afraid of the black guy not just signing the permits, because black guys always sign the permits. These are nations. They're worried about the black guy who knows how they screwed up in the field and who might stop them from going back next time and trashing the fossil or not getting the proper DGPS readings on the ark. They don't like the black guys like that. And so there's a huge inertia and a status quo that has to be overcome in the areas of gender, in the areas of race, in the areas of third world development, and so on and so forth. We kind of made a start at it here. I think we've been successful some of the time. Don't ask me to tell you about the failures. I've had lots of them. I've had 5 Tanzanian students. Not a single one of them is now a professional paleoanthropologist. Closest we've come is, junior college in California. But you keep trying and you get successes, and you got to do that in order to move the thing off of ground zero.
I think it's getting late. We're going to turn over many other questions, but Robert, Robert, you can have the last question.
All right. Well, I hear you talking about you're finding all the teeth that's really old fossils, and it seems to me like the teeth will be the first to wash away because they're smaller and they're lighter. Why is it that they fossilize and we find more of them than any other bone?
Well, think about the hard tissue that you can access. Which are the ones that are out there subject to the environment? See, teeth, right? They're right here. You feel them. You can see them. They're great. They're hard as hell. They're the hardest part of your body. Right? Covered with enamel, really super hard material, easily replaced. There's hardly any organic material in it to start with, right? So now take your body, feed it to a hyena. I'm not saying do this at home. And see what gets left, right? The one thing that hyena can't process is your teeth. And so they go like that. Yeah. And that's the fossil record. And that's why skeletons are so extraordinary. Because for some reason, the hyenas didn't get a hold of them. And more than just the hard parts are found. There's a cartoon that an artist did years ago to represent the fossil record of a mammal, just a generic mammal, in terms of the relative frequency at which we find various body parts. And this animal has enormous teeth and jaws and a little tiny body and no vertebrae, right? Because those are the soft parts. Those are the parts that disintegrate first. So even though teeth are small, they're really hard, and that's why. And the other cool thing about teeth, they do interface with the environment, so they pick up environmental signals. They're composed during growth, during ontogeny, so they pick up geochemical signals. You can measure the isotopes in them. You can look at the scratches on them. They tell you about development in the jaw and developmental anomalies as the animal is growing. So teeth are just awesome for all those reasons. And you can just look at the shape of it and figure out, is this a grazer, a browser, an elephant, a hyena, or a hominid? So teeth are really important in paleontology. We use them all the time.
Okay, we're going to do that. Thank you. We have to get him up in the morning and go to another high school. So we're
Thank you.
I met your chair. Hi, Cheryl. Right into your chair. You were there. And this is just